Can everyone hear me? All right. Good morning. So my name is Odazie. Today I'll be talking about cloud native technologies, the building block of modern database software, right? So the title is quite a mouthful, right? And I'll see how we'll cover that in 30 minutes or so, 25 minutes. A little bit about me. Like I mentioned, my name is Odazie. I'm a technology evangelist at several nines. I'm an electronics engineer by my college degree. I'm a certified Kubernetes application developer and also a data on Kubernetes ambassador, because there's the data on Kubernetes community that kind of works hand in hand with the Cloud Native Computing Foundation. And I'm excited to be here and speak to you all and share. I'm not a Kubernetes expert, but I would say I'm a fan and I know some things that I could share, right? Just the agenda of today's talk. So I'll start by just giving a brief history of database deployments, right? And then talk about cloud native technology is what it is, right? Then introduce you to like stateful workloads on Kubernetes. Then talk a bit about building DBaaS on Kubernetes and building a DBaaS with Kubernetes. Then conclude. So the first, the brief history, right? So I wouldn't say this is a kind of like a rigid history, right? But like ish, especially looking at the dates, right? Because we can know that databases started with mainframe computers. A lot of organizations still use mainframe these days, right, to store their data, right? So I know a lot of people that I work with my company, right? A lot of customers still have database deployments on mainframe, right? But this should give you an idea of where it all started, right? As we scale database deployments. But then again, these early days there was a rigid data model and also challenges with cost, and like it's quite expensive to host data on mainframe computers, right? And to solve these problems, right, I think it's an Englishman that worked on that proposed the idea of relational databases, right? And that's brought about the way we structure data today. We see from relational database to NoSQL, and there are different types of database architectures, right? And also several advancements in technologies that brought about smaller servers, and like you can host a database on your computer, and like several other advancements, right? And where we come to Kubernetes as we go on containers. So moving on pre-cloud, on-premise environment, these smaller servers being stored in an organization. This is not to say that on-prem environments are not still being used today, right? A lot of organizations use it for their data to meet some requirements, right? Data compliance requirements or latency requirements. And but this introduced the age of cloud computing in order to solve the challenges that on-prem had from initial starters, right? We all know this. When someone today wants to build a software, the first thing, especially being a startup or a one-person shop, right? It thinks about going to the cloud. That's not spend cost of deploying an application, right? Or a database in this case. So the cloud era, cloud managed databases, we all know about RDS, Cosmos DB, and all the likes from the major cloud providers and from DigitalOcean and the likes, right? So they simplify the use of databases, right? The deploying from the abstracted away, the provisioning of the servers, right? And gave so many features, right? Both on scalability aspect and offering limitless scale, right? In quotes, right? But then again, this model has its own challenges, right? I don't know if you've attended some talks that talked about the challenges of cloud from cost and several other scenarios at scale. And then container revolution, right? Kubernetes, as we know, as a de facto container orchestration tool, right? Docker leading brought about containers, right? Anyone, like I think a speaker spoke the other day that he gave a highlight, a quote that these days we don't say it works on my machine, why isn't it working on yours? So because of like containers made that easy for us to share and deploy applications, right? And Kubernetes came about as a de facto. There are many container orchestration toolings, Nomad and Mesos, right? That some organizations still use, right? And use. But when you think about container orchestration today, mostly what comes into your mind, right? And the community will say Kubernetes, right? And then the road to database on Kubernetes started with the introduction of stateful sets, like they were initially called PET sets, right? In version 1.5, released in 2016. So, this is just like a summary diagram of the road to database on Kubernetes. And now to the main part of this talk, right? Cloud native technologies, right? So what are cloud native technologies? So cloud native is practice, right, that empowers organizations to develop and build workloads, build and deploy workloads, either on-prem, right, private cloud, hybrid cloud, wherever you want to deploy your application, work with that cloud first focus, right, in the aspect of that it prioritizes skill, prioritizes flexibility, prioritizes agility, right? And is characterized by its loosely coupled architecture in the sense of like containers, from containers, pods, deployments, and their different layers, right? And then again, cloud native technologies. When you hear about cloud native technology, the first thing that comes to mind for someone that's not really into this space, you say is mostly synonymous to Kubernetes, right? But then again, it's crucial to understand that there are several cloud native technologies out there, right? And Kubernetes, we say, is like the key piece, because most of them, you can say the platform stack that work hand in hand, right, for you to deploy the application, right? So it's just a piece of the architecture, and I would say the key piece, right? Then, yeah, the cloud native computing foundation, like I've talked about, is the testament of the length and breadth of the cloud native ecosystem, standardizing the way like you build and test. There's the incubator, the graduated projects, and sandbox project, right? So that gives assurance to end users in order to use this cloud native technology to deploy applications. And this is just a screenshot of a part of the cloud native landscape, right? And these projects work hand in hand, right? Depending in a vendor neutral environment. So you can see there are several application definition and image build tools, right? So you choose what you want and what you need in order to deploy your application. So this is the power of open source, right? The essence of open source not being tied down, right? Then to the main part of this talk, right? Stateful workloads. So introduction to stateful workloads on Kubernetes. Seeing Kubernetes as a de facto container orchestration tool, right? Let's look at the building blocks, right? So it's not only Kubernetes that you can deploy stateful workloads on in a cloud native environment, right? But seen as a de facto, right? What is being talked about, what is being used by most organizations, right? Let's look at that. So first, what is a stateful workload? So a stateful workload, you know that any workload that you need to persist that data over time, right? Across restarts or failures, right? Example, databases, which is the core focus of this talk, game servers, ML application, different types of applications, so long as you need data to store over time, right? In case of failure. And they require meticulous orchestration, right? I don't know if anyone here have worked with databases. Databases are a complex piece of software, right? It's not really straightforward, and you need some experience and some understanding, right? And stateful workloads, generally, they're characterized by some challenges, right? In the aspect of maintaining a consistent identity, like database connections, right, over time. And also dealing with day-two operations, upgrades, right, patches, and backups, right? So these are challenges that stateful workloads face. Just being a stateful workload, whether be on VM or be on a VM or bare metal or wherever you deploy, right? Then, if you didn't know, Kubernetes was originally designed for stateless workloads. So imagine having these challenges, a regular stateful workload on VMs, right? Having these challenges, right? Then bringing it to Kubernetes, right? That is stateful by default. So how will you stateful by default because of the idea of containers being feral, right? Or being you want to scale easily, right? And destroy containers and scale down when need be. So how can we tackle these challenges in a Kubernetes environment? So that is where I'm going to talk about and give some more in-depth overview, right? On the deployment aspect, like I mentioned in the road to database on Kubernetes, we have the stateful thread. So stateful threads, right? It's just like a deployment. In deployment in Kubernetes, you deploy pods, and these pods have containers and init containers and several layers. We can go in depth on that, right? But stateful thread does that in that way. Right? But the special thing about stateful threads is the fact that it has a sticky identity for the pods, right? So you know that connection is consistent, right? Over time, over the life cycle of the database, right? And then jobs that you use, like you want to backups, right? Consistent backup to schedule jobs, right? That's on the deployment aspect. But then again, you deploy an application, it's beyond that, right? Whether it be an application or whether it be a database, and database being complex, right? Lifecycle, data operations, monitoring, backups, like I mentioned, right? That is like where the challenges become more persistent, right? And it becomes a struggle. So how do we solve those challenges in the Kubernetes environment, right? So from the era of stateful sets and several innovations in the Kubernetes space, right? Operators became prevalent, right, as a way to deploy databases on Kubernetes, right? So I don't know if anyone here have used is there anyone here that have used the database operator to deploy it? Yeah. So You can talk about, if you've said it in the early stages, right? You can explain how it was quite complex at the beginning, and it's getting better, right? There are more stable operators, right? And majorly, I see more operators on Postgres, deploying Postgres databases. We have the Zalando operator, we have the EDB operator, right? And these operators help tackle challenges like high availability, backups, upgrades, right? And but then again, these operators, there is not enough. There are different types of databases, right? There is not operators for every kind of database. That's what we need to understand. So you won't say it's every kind of database you want to deploy that you see a stable operator out there for you, right? But this is what we will focus on in the later parts of the talk, how operators are helping deploy and manage databases on Kubernetes. So how does Kubernetes handle this storage, right? So I kept talking about automation, upgrades, and stuff, right? But the data has to be stored somewhere, right? So Kubernetes is stateless, right? The data has to be stored. How would Kubernetes handle that storage? And that is where persistent volumes come into play. So I don't know if you've heard of PV, PVCs, CSI. There are several patterns, right? So there's a data on Kubernetes white paper. I maybe after this talk, I can share you the link to it. It's created by the Data on Kubernetes community. It offers some in-depth overview and understanding of how to deploy these databases, right? So just to summarize, so persistent volumes, right? They give you the piece of storage, right? They abstract the access to the particular data, right, where the data is stored, whether the data be stored on a cloud-specific storage, right, or whether they be stored or on an NFS, right. Then this PV, right, in order to use this PV, you need to write a persistent volume claim, so a PVC. But then again, a persistent volume claim, you use to claim that particular storage, you use it to access for the pods, right, to access the data. But then again, you can think about it, right, the PV and PVC, they have a one-to-one relationship. And earlier on, when I started learning about data on Kubernetes, right, I was like, okay, why do they have a one-to-one relationship, right? Why shouldn't I just connect to a PV, right, a persistent volume, and access the data? But then I read more about it. I understood the abstraction layer. So not everyone, if you use Kubernetes, you know that expertise, right, from the developer perspective and also from an administrator perspective, there are different layers, and a PVC abstracts right, abstracts from the developer to worry about the layer where this data is stored. And now you will not have to worry about, okay, is this an NFS storage? Is this a CPHS storage? A Kubernetes developer will not have to worry about the intricacies of the story, but just know what they want, right? And write the YAML configuration for that particular claim. Then moving on to a container storage interface. So this is a standard API on how you access that vendor data, right? That database, wherever it may be. So there are different types of CSIs or for different type of major cloud or providers, VMware, AWS, and EBS volumes and stuff, right? And all these come together to give you the features of dynamic provisioning and help you to be able to take snapshots, clone your data, all through the portable persistent volume APIs. And there are other aspects of storage persistence in Kubernetes, right? Like storage classes, we can't really discuss in depth because of the time frame, right? I have only 10 minutes left. But this gives you an idea of how data is stored, both from a user trying to deploy the data on Kubernetes and the data being stored wherever the data is persisted. Then if you put this all together on this flow diagram, see that the user submits a configuration, and this configuration is defining the desired database cluster, right? And the operator processes the request, right? Creates a stateful set. Then the stateful set creates a pod, right? In order to, and each pod depends on how you want to access that data, right? In most cases, it's advised in production environment that each pod should have its own persistent volume claim, right? For the persistent volume, right? Then the database application within the pod using the persistent storage to store data, and the operator continuously monitors the cluster and performs tasks, right? From scaling the stateful set, handling pod failure, and performing backups, right? Mentioned, there are many aspects through databases on Kubernetes and data on Kubernetes in general that we can't really talk about, from upgrades and disruption with node affinity, taints, and pod priority, and several other aspects, right, in order to make sure that you're not just to handle day two operations beyond just deploying your database on Kubernetes. Now, like seeing how all this come together, right? A regular, I mentioned going from the history, the presence of DBaaS, right? DBaaS made it easy for anyone to deploy a database, right? So most end users, most people that want a database want that like user interface, right? Wants that DBaaS like experience. So they don't want to worry about clicking, don't want to worry about YAML, writing YAML configuration and all that, right? That I've just talked about. And then you don't want to worry about all that I've just talked about, right? And these managed DBaaS like RDS, right? They offer this feature out of the box, right? But then again, there are some challenges that I know some of you must have experienced from, vendor locking or becoming more expensive over time, or having to find expertise to manage it. Yes, it's a managed DBaaS, right? But you need some expertise, especially from query optimization and some other DBA specific tasks, right? Some understanding of how the database works and how the system works is needed, right? And because of all this, right, organizations have started building their DBaaS on Kubernetes, right? Whether it be it their internal DBaaS or external DBaaS offering to customers, right? And that's what we'll discuss next. So building a DBaaS on Kubernetes, there is a lot of aspects to building a DBaaS, right? And I just talked about how data on Kubernetes works. Then in the real world, right, in production, a user wants a way, you need a way to manage users, right? You need a way to apply schemas, secrets, authentication, single sign-ons, right? Like maybe you're using LDAP, you have to put that in consideration, right, for that particular database. Then, backups, right? Day two operations, monitoring. How will you monitor your databases, right? Then you now talk about like where are you deploying that Kubernetes cluster, right? There are several aspects to consider, right? Several aspects that a DBaaS need, and all this a DBaaS need. But then again, the end user, like I mentioned, wants a simple interface they can use. Whether it be developers, they'll prefer APIs, or some people want to use CLIs, but most people are more interested in UIs, right? Like a nice, shiny user interface. They want to point and click to make stuff happen, right? And not worry about the abstraction layer. Then again, how will you be able to achieve this, right? With Kubernetes, let's say you're not using like a big managed provider. There you have to choose between being independent and interdependent. So being independent, right, is you do everything from scratch. You build your custom software to handle jobs within the DBaaS framework. This requires like a lot of expertise, right? I just mentioned and discussed a hint of databases on Kubernetes. And then being interdependent is finding a middle ground between building custom software that do specific jobs and using off-the-shelf tooling, right, to build out your DBaaS. And in the CNCF space, right, I don't know if you guys have heard of a company called Odazie. So their CEO gave a talk. He was among the early contributors to RDS in the early days. Gave a talk and this is the final architectural diagram, right, of building a DBaaS somewhat with cloud native technologies. As you can see, Argo CD handling the workflow using Keycloak for access management, monitoring with Cilium, Hobo, NetData, Prometheus, and like a lot of things that go all in all, right? And using operators to manage the database and managing the state of the databases, right? And upgrades and other data operations. A lot of things go hand in order to make this possible, right? From the Kubernetes space. Not every company, not every organization, not everyone has the expertise and the time, right? Especially looking at the way the ecosystem is to invest in doing that, right? And some more companies are building toolings and building infrastructures that kind of like abstract all these layers, right, for organizations to be able to implement database on Kubernetes and databases on Kubernetes. And my organization is one of that, right? And we worked on a do-it-yourself, right? We all like DIY. If you're on YouTube, everyone likes a DIY. So we worked on a DIY guide, right, on how to build your DBaaS yourself. So it's about 20,000 words, right? It's an in-depth guide that goes from day zero to whether you want to shut down the entire DBaaS, right? Handling day two up from requirements, architecture, design, installation setup. You can scan this QR code to be able to read on guide, right? So we created this guide using DBaaS. I don't know if you've heard of DBaaS, right? As a layer for handling the infrastructure provisioning, right? And this guide, I would say it still makes it helps you, right? Like a guide, right? It helps you in order to move to achieve that. But then again, it still requires some investment, right? And some understanding, right? And now, next, we'll look at who built a DBaaS on Kubernetes. So like I mentioned, I don't know if you recall, I mentioned Zalando, right? Having the Postgres operator, right? So since as far back as 2018, they've been doing databases on Kubernetes at scale, managing like 500 plus clusters, right? And they are the creators of Patroni. If you're in the data base space, you know about Patroni for a high availability template engine, right? And also Shopify have their own DBaaS as a service on GKE, Kate's SQL, right? So this is something that have been done since early on, right? But then again, these are pretty huge companies with a lot of resources and a lot of engineers, right, to spend to achieve that, right? They have contributed a lot by Zalando providing the Postgres operator, which organizations now use today, right? In my organization, we use the Postgres operator, right? And there are several operators out there. And this is just to show database on Kubernetes is being used. If you I asked a few people since coming to this event yesterday, right? Will you put on your data on Kubernetes? Some people said no, some people said yes, right? Not everyone would support, right? Everyone that have the experience with database, not everyone will support putting database on Kubernetes, right? Because of the challenges of databases on their own, right? So this gives you like an encouragement that there's been a lot of improvement over time, and there's been a lot of investment both on open source resources and expertise, right, to bring it to this scale. Yeah, like I just mentioned, I think I mentioned it before reaching this slide. Not everyone wants to put their database on Kubernetes yet, right? But then again, how will you enjoy the benefits on Kubernetes without having to move your workloads from VMs, right? And is that even possible? And there, I would say yes, right? And that's what my company have been working on for the past 2 years, right? Using Kubernetes to meet some organizations in some highly regulated environment, let's say in the US, right? They are quite peculiar about their data, right? They are quite, I was on a call a few weeks ago, and the person I was talking to mentioned he doesn't want to hear about data and Kubernetes being put together in the same sentence, right? And this is a pretty huge organization in the US, right? That's catering to millions of customers, right? So a lot of people like, okay, yeah, Kubernetes is nice. They deploy their stateless or workloads, their application on Kubernetes. They scale as they want, right? They deploy their cluster using VMware, Tanzu, or EKS or so. But then again, not their database. Okay, hires their ML application, right? So building a DBaaS with Kubernetes, that's what I want to talk about next, right? So in the act, building DBaaS with Kubernetes is, the data is not stored on Kubernetes, right? But Kubernetes is used as a control plane to manage the deployment of the database and also the day 2 operations. So just to mention the product my company has been working on for the past few years. So it's called CCX. And, I see my time is up. I have how many minutes left? 5 minutes left. So basically, the Kubernetes-based control plane, right, that abstracts away most of this manual initial engineering effort, right? And it's designed in a loosely coupled architecture in the sense that you can easily use, I will go to the architecture diagram, you can easily use the different Prometheus-based metric server, right? Instead of Victoria metrics, you can switch it off from ClickCloak, you can use a different DNS, right, in order to deploy your DBaaS. And then on the data plane aspect, you can deploy your database on AWS, right, if you want. So AWS EC2 raw EC2 instances. And this gives you that control in avoiding vendor lock-in, that if you decide one day you want to move from AWS to, let's say, DigitalOcean Droplets or something similar, right, or on-prem VM, you can move to that. And also integrates with OpenStack, integrates with VMware. And these are currently the databases that we currently offer, and more support are coming. And like DevOps engineers, we want APIs. We want to use Terraform to deploy our database. Not everyone wants a UI, right? So there's a Terraform provide a public API, right, that you can integrate to your DevOps workflow. And we have been working on this for the past 2 years, right? And we recently, a few months ago, went on general availability. And we had a lot of companies, right, using this DBaaS. And the installation steps, just to give an overview, you first deploy all the dependencies, which are those, the core DBs, the ingress controller, and the operators that needed to manage the automation of the database, right? And the UI, your authentication services, and then the observability stack, because you need to know what's going on in your database, right? And all these are public via Helm charts, and you can easily download it and tweak and break and make any change you want, right? And also on Artifact Hub, and you have a detailed documentation with some quick start and guides that can help you in that. And so who is using CCX, right? So I don't know if you've heard of Elastic, the Swedish cloud provider. They use CCX to implement their DBaaS, right, that they offer to their customers. And also Lintasatra Cloudeka, we gave a talk early this month at the Open Infra Summit in South Korea about how we're able to achieve this with Lintasatra, right? So it's being used by organizations, right? But the good thing I would say about CCX, and why I can proudly talk about it, is the fact that you can choose to use any underlying technology if you want, and you're not really tied in, and you can easily take it out. I think that is what everyone that wants a DBaaS needs now, to be able to take it out because of cost, or use it like to save cost, or use a different tooling. Let's say their engineers are not that conversant with Keycloak, or they have not used Cilium before in the past, or Hubble. So that gives you that flexibility, and with less time spent on R&D, right? And this being used, right, we're having more contributors to our GitHub project, and that gives you that assurance that it's being used, and the support, I would say, is excellent. But I'm just plugging in my company and the product I've been working on for a while. Just to wrap up, right, the journey of database development is far from over. There's still there are more ways to come about how we deploy and manage data, right? Cloud native technologies, particularly Kubernetes, offer powerful scaling and several features. But then again, with much power comes great responsibility, right? I think that is the best way to put it. So you have to find the fine line, right? And building and integrating a DBaaS on Kubernetes can streamline your operations, handling scale, and also being open source and not being locked in, because like you can use a different cluster, whether it be moving from VMware Tanzu to AWS EKS or some other architecture, right? And yeah, if you would like to learn more about CCX, you can easily scan this code. And thank you very much for your time. There's not more time for questions, but you can always ask me questions. I'm still around in the conference. Thank you very much.